Welcome to part 2 of the rational function notes. This would be graphing rational functions. If you are unfamiliar with any of the parts we talk about in this video, you're welcome to watch part 1 where we go over the pieces and how to find them. Please be aware you can find any of the pieces, the x-intercept, the y-intercept, holes, vertical asymptotes, or horizontal asymptotes in any order. So let's jump on into example 1. G of x equals x plus 2 divided by the quantity 2x plus 6. Let's start with horizontal asymptotes. For that, we're going to remember the acronym BOSTON. When the bottom degree is greater than the top, y equals 0. When you have the same degree on top and bottom, you have a ratio of leading terms. And when the top is greater than the bottom, there's not a horizontal asymptote but slant. In the first example, the degree of the numerator is 1 with a leading coefficient of 1, and the degree of the denominator is 1 with a leading coefficient of 2. So my horizontal asymptote will be a ratio, since it's the same degree, will be a ratio of leading coefficients, 1/2. So here, y equals 1/2. Now we're going to factor a polynomial in numerator and denominator and analyze the factored pieces. The factored form of my polynomial is x plus 2 divided by 2 times the quantity x plus 3. Now let's look for some discontinuities. We have a whole when we have the same factor in both the numerator and denominator. Since that's not happening for this example, there are no holes. We have vertical asymptotes when the denominator is equal to 0. So that would happen at -3. So x equals -3 would be my vertical asymptote. Now we're down to the x and y intercepts. The x-intercepts occur when y equals 0. The y-intercepts occur when x equals 0. So let's start with finding our x-intercepts by setting my numerator equal to 0. This occurs when x equals -2. So my x-intercept will be when x equals -2. Finally, we're going to find our y-intercepts by replacing all x's with 0. So 0 plus 2 divided by 2 times 0 plus 3. When I simplify that, we're left with numerator of 2 over 2 times 3, which is 6, or 1/3. So my y-intercept will be when y equals positive 1/3. The last thing that I'm asked to do for this example is find g of 4. So similar to the y-intercept, we're going to plug in 4 this time and evaluate our function. So we have 4 plus 2, which is, as we know, 6, over 2 times 4 plus 3. Well, 4 plus 3 is 7, times 2 is 14. So 6/14 will simplify down to 3/7. So g of 4 would be 3/7. Now let's look at example 2. Notice 2 is already in a somewhat factored form. So when I look for my horizontal asymptotes, I'm going to look for my degree, which is my number of x's. In this case, my numerator has a degree 2, and my leading coefficient is a 5. In my denominator, my degree is also a 2, and this time my leading coefficient is a 3. So same degree in top and bottom means I have a ratio of leading coefficients. So my horizontal asymptote will be y equals 5/3. Now let's look at the completely factored form. Notice the only thing factored out was a 3 in the denominator. Now let's look for our discontinuities. As I'm looking at this, I see that I have a factor in the numerator and the denominator, x plus 2. Since it's in both, that creates a whole at x equals -2. To find the value of my whole, I'm going to reevaluate and look at what would happen at -2 if the whole were removed. As you can see, I removed the issue and I'm left with 5 times x plus 3 divided by 3 times x plus 1. So I'm reevaluating the function at -2. Plugging in -2, in the numerator, -2 plus 3 is 1 times 5 is 5. In the denominator, negative 2 plus 1 is negative 1, times 3 is a negative 3. So that means I have a whole, a value that doesn't actually exist, at negative 2 and negative 5/3. Moving on to my vertical asymptotes. Notice I have a denominator, x plus 1, that hasn't been accounted for. That means I have a vertical asymptote at x equals negative 1. Next, I'm going to look at the x and y intercepts. Remember, the x-intercept occurs when the numerator is equal to 0. We've already looked at our x plus 2 problem. The only thing we have left in the top that could be equal to 0 would be x plus 3. Therefore, I have an x-intercept of negative 3. To find the y-intercept, I'm going to look at f of 0. I'm going to plug in 0 for x in the numerator and the denominators. So we have 5 times 2 times 3, or 30, divided by 1 times 3 times 2, which is 6. 30 divided by 6 is 5. So my y-intercept will be 5. The last thing I'm asked to do for number 2 is to evaluate f of 5. I'm going to scroll up and give myself a little bit more room. I'm going to plug in negative 5 into the function. As I simplify, I have 5 times negative 3 times negative 2, which is a positive 30 in the numerator, and then negative 4 times negative 15 plus 6, which is a negative 9. So that's a positive 36. That simplifies down. Well, 6 goes into 35 times, and 6 goes into 36 6 times. So f of negative 5 is 5/6. If you think you have the hang of it, go ahead and pause this video and try examples 3 and 4. For those of you that would like to check your answer or you need more help on 3 or 4, I'm going to go over them now. Starting with end behavior. The degree of the numerator is 1 and the degree of the denominator is 2. Since the bottom is greater than the top, y equals 0 for my horizontal asymptote. Moving on to the discontinuities, the factored form would be x plus 12 over the quantities x plus 12 times x minus 2. Notice I have a common factor in the numerator and denominator that can be removed, so I have a whole at x equals negative 12. And just like we did earlier, what we're going to do is simplify this, and it becomes 1 over x minus 2, and I'm going to evaluate at negative 12. F of negative 12 is negative 1/14, so we have a whole at negative 12, negative 1/14. Notice there's still one factor remaining in the denominator, so that is my vertical asymptote. So my factor x minus 2 means I have a vertical asymptote at x equals positive 2. Notice that there are no remaining factors in the numerator unaccounted for, so I have no x-intercepts. Therefore, I'm going to look for my y-intercepts by evaluating f of 0. I can use the simplified form of 1 over x minus 2 to evaluate f of 0 and get negative 1/2. So my y-intercept would be at negative 1/2. The last thing I'm evaluating is going to be h of negative 2, not f. And I'm going to use this simplified form one last time. Reduces my work just a little bit. As you can see, h of negative 2 would be 1 over negative 2 minus 2, or a negative 4. So h of negative 2 is a negative 1/4. Finally, the last example, k of x, is x squared plus x minus 12 over x minus 3. As you can see, the numerator is larger than the denominator degree, so as far as horizontal asymptotes go, this one doesn't have a horizontal asymptote, only a slant. Lucky for me, this one's also going to factor, so you're going to see what the end behavior will be in just a couple of moments. So the factored form, x minus 3 times x plus 4, does a couple of things. Notice how we have a common factor in the numerator and denominator of x minus 3. And what does that become? A whole. So the whole is at x equals positive 3. When I reduce this, we're left with x plus 4. And so if I find f of 3 now, 3 plus 4 is 7. So my whole will be at 3, 7. This also gives me my end behavior. My end behavior is going to happen with my remainder, not remainder, remainder is the wrong word, my quotient. X squared plus x minus 12 divided by x minus 3 is x plus 4 when simplified. So my quotient would be x plus 4. So I have a slant at y equals x plus 4. And that makes sense because what this looks like, if you graph it, is x plus 4. The only problem in it happens at -3 when we have our whole. So you're going to look at the graph of this and it's going to look like a line, but if you trace at -3, you're going to see it doesn't exist at just that -3. There's no more denominators, so I have no more vertical asymptotes. And now we're left with our x-intercept and y-intercepts. The x-intercepts occur when my numerator equals 0. So x plus 4 equals 0 at -4. So x equals -4. And the y-intercept occurs when we look at f of 0. So f of 0, 0 plus 4 is 4. So my y-intercepts will be +4. Finally, we're going to evaluate k of 1. If you haven't noticed, I am going back to this simplified version for my x-intercept and my y-intercept. And I'm going to also use that simplified version to evaluate. So 1 plus 4 is 5. So k of 1 is 5. Thanks for watching through these examples. If you have any further questions, don't hesitate to ask your teacher. Have a great day.